Hello, everybody. My name is Connor Gregoire, and I'm here to talk to you about the urban heat island effect of Westfield State University. Many ask what the urban heat island effect is, and this occurs when there is a highly populated area and it tends to be warmer than rural areas. Some statistics are that cities with more than 1 million people have a mean air temp of 1.8 to 5.4 degrees Fahrenheit higher than surrounding areas. Why the urban heat island effect matters, it is because it can increase summer energy demands, increase air conditioning costs, it can cause air pollution, it can cause a decrease in water quality, and it can also cause heat related illnesses and mortality. In order for me to determine if there was an urban heat island effect on campus, I had to collect data, and to do this, I deployed 12 data loggers across campus and off campus. I put them in areas where there was grass, areas where there were woods, and used them in high concrete use locations. All of this was done with help of my classmates in my data collection analysis class. We used three different types of data loggers. One was the hobo pendant logger. This is the cheapest, and it records temp and light. We also used the Hobo Water Temp Pro V2. This is a temperature logger that records temp and it is also waterproof. I also used the Hobo U23 Pro V2 logger. This records temperature, relative humidity, and this is the most expensive out of the two, costing around $150. Here are pictures from the data logger that was deployed on the football field. It's right on the goalpost as shown in the pictures. Here is the Hobo U23 Pro V2 that was hanging in the tree right between Bates and Wilson Hall. So once I collected this data and brought the data loggers back to the classroom and put the data onto the computer, I put the spreadsheet onto Excel and then averaged every day that the data logger was outside and made it into a chart. As you can see on the PowerPoint slide, is I direct labeled the highest number, the highest degrees in Fahrenheit, and I also labeled the lowest degrees in Fahrenheit. Here on the grassy area near Bates and Wilson, I did the same thing and direct labeled the highest temp and the lowest temp. And here you can see that there is a dramatic difference on the temperatures. There's a 33-degree difference in just 17 days. And then lastly, here is a comparison of both the data loggers. The orange is the football field, and the blue is the grassy area between Bates and Wilson Hall. And you can see I also direct labeled the highest and the lowest for both locations. And you can see that both the highest temperature is higher and the lowest is always lower on the cooler areas. What does this information mean? This means that grassy areas will be cooler than areas near artificial grass and concrete because those things can retain heat better. The grassy areas will cool down faster because they don't have the well of a retaining heat. Westfield State University could cause an urban heat island effect, however, it is unlikely. In order to do so, there would need to be a much larger scale, such as a giant city like New York City. Another thing is that grass will have a lower nighttime temperature. So overall, I don't believe Westfield State causes an urban heat island effect, but there are areas on campus that will be hotter than others, such as the football field or a huge parking lot. The grassy areas will be lower. Here's my works cited, and thank you for listening. So, in order for me to determine if there was an urban heat island effect, I wanted to choose two completely different locations. One that would have a one that area that I would think would have a higher temperature than the other, which was the football field. This one has no grass, no shade, all daylight exposure. Not many structures near it, track all the way around, and concrete surrounding it. The one that I was hanging in the tree, this was on campus, and it was in shade and an abundance of grass nearby, and there was some concrete close, but not very close.